All right, so what crazy contraption have I built here? Well, as you can probably tell, it's a clock, but this is a rather special one in that it's an extremely precise clock, and by precise, I mean it shouldn't lose more than a second or two a year. And I base that off of this thing right here. This is what inspired me to begin this project. It's a Vectron 10 megahertz oven-controlled oscillator. This is a pull from a cell phone tower, and what's special about it is that it's incredibly stable, with a precision in the ballpark of 50 to 100 parts per billion. So translated into real-world conditions, it's about 1.57 seconds, give or take. I do expect a little bit of drift with that, but overall, well beyond any intended use case I would ever have for a timekeeper. Now, to get a precise signal, I do want to make sure that it has a really precise power source. So what I've done here is I've taken 9 volts from the wall wart, and I've regulated it using this buck converter down to exactly 5 volts. And then I have some additional components that are basically going to clean up and guard against any transients and so forth, just to make sure this thing's sitting at exactly at 5 volts at all times. So now that I have this exactly at 5 volts, the next thing to do is to figure out how to take this 10 megahertz signal and divide it into something useful. I can't just really time directly off of 10 megahertz. The intention for this is to go into a microcontroller, say like an Arduino, that's going to have 16 megahertz, and just trying to count 10 megahertz for the 16 megahertz processor is a little bit taxing. It doesn't leave any room for the ISR to do things or for interrupts to run correctly, so you really got to start dividing this down. Now, a common way to divide a high frequency into a low frequency would be using dedicated logic circuits. They typically have different IC packages for this, and you just kind of chain them together, and you can divide down your frequencies that way. I've decided to take a one-stop shopping approach, and it so happens that I happen to have a lot of these ATtiny 85s lying around, so I decided to use one. But what is an ATtiny 85? Well, think of it as the little brother to the ATmega 328P, which is your common processor for your Arduino. It's in the AVR family, and the only difference is that it's 8 bits, and it's a lot smaller, and you got to be a little bit more deliberate in how you use it, simply because, well, it can't count very high, right? And if you're trying to divide a large number into a smaller one, it definitely helps to have something like 16-bit registers, which this does not really have. So I had to be a little bit creative in terms of coming up with an approach to take a 10 megahertz frequency and step it down. So the first thing that I'm doing here is that I'm taking the 10 megahertz supplied by the Vectron and using that as the native clock speed for the ATtiny 85. But I am using a fuse setting to then divide that down to 1.25 megahertz. Now, within the ATtiny 85's execution path, I wanted to ensure that the overhead was kept as low as possible. This is, after all, an 8-bit microprocessor, so it really can only count up to 255 before you start having to get into overflows and other things that can really just sort of complicate your code and then also just create potential sources of imprecision. So what I've done here is I pre-scaled the signal 8 divisions further, and then I'm only counting up to 125 ticks and then sending out a pulse, right? That translates to a pulse being sent out every 0.0008 seconds or 0.0016 for the entire period. In essence, this will send out 625 pulses per second. So for a 16 megahertz processor like the Arduino Nano that I have set up here, 625 intervals per second leaves plenty of clock cycles for it to do what it needs to do. And what the Arduino itself does is relatively straightforward. I have it running an OLED display right here with some time construction, and I have a day-date functions and a sunset calculator, because I like to know when the sun sets. And then I have a rotary encoder, which I'm using to basically control everything. And this is simply my convenience. I really don't like the way alarm clocks work. You got to push a lot of buttons. You got to cycle through things, are slow. I did this rotary encoder implementation because I want to be able to just kind of whip through the values really quick and just kind of set things fast. And then you can kind of see I'm indexing through the different settings right here. And then I even added a fine-tuning section right here since I want to compare this against NIST. So I have it so that I can actually synchronize a second right up to the national standard. What's interesting is I've been running this for a few days. I'm trying to calculate error. I'm not finding any. It's hard to measure error when you don't see it. I imagine with enough time I might start to notice some drift, or I could find another way to calibrate it. But what's amazing to me is that so far this thing has not shown me any error whatsoever. It's basically on point with the national timekeeping standard. So next steps for this project. Well, I need to get it off the project board and put it on some proper perf board like I did with the Vectron. I'm going to add some alarm functions. And as you can see right here, I already have sort of a date set up. You know, it kind of calculates day of the week based upon the calendar date. And then, of course, underneath I've got my sunset calculator right there. It's just working off my local location. So another convenience that I have. And then I will also be designing a 3D case for this. Of course, I need to get it off the perf board first, and then I will cover it with this walnut veneer that you see underneath there. I actually kind of use that for a lot of my projects, my speaker project as well, which I have on my website. I happen to think that walnut will make a very dressy case for this project, and I'll be sharing the build steps as I go along, but pretty excited about this project and wanted to share it with you all, so let me know your thoughts. Thanks a lot.